Welcome back. We're going to look at how we can sketch the graph of cosine, like the cosine graph, right? The parent graph that we have for cosine graph is f of x is equal to cos x. But actually, we want to look at the effect of these parameters. We're going to look at the effect of a, the effect of k, the effect of P, and the effect of Q by using these different graphs that we have here. So we're going to start with the graph of f of x is equal to cos x. Right, I'm going to use different domains here. I'll be changing the domains just to make sure that you understand how we sketch this graph. So this is the graph of f of x that we have here. Okay, I'll call it the parent graph. Okay, so before we even start, we have to understand the parent graph. So let's discuss the key features of this graph, which is for f of x is equal to cos x. Right, what are the key features of this graph or the critical values? Right, you must know that this graph starts where? At 0, this graph is at 1 there. Okay, cos 0 will give you 1. Please know that. And then the critical values are at every 90 degrees. Right, like from 0 to 1 at 90, the graph is at 0. And then another 90 degrees, from 90 to 180 there, the graph is at negative 1. And then another 90 degrees, it is at 270. And then 90 degrees, it is 360 degrees. So you must know the critical values of this graph every 90 degrees. And then even going to the left, if we say 0 minus 90, we get here, we have 0 there. And then negative 90 minus 0, we get to this point here. Okay, see that every 90 degrees. This is very important. Okay, I'm going to show you how we can sketch this graph using the parent graph and also the calculator. Right, let's start with the first one. We have the graph of f of x. Let's look at the graph of g of x. Let's say g of x is equal to 2 cos x. Now, what is the effect of 2? In this case, which was a here. What is the effect of 2? The 2 does not affect the x-intercepts, but it does a vertical stretch of the graph. Okay, so it means the maximum and the minimum values are the ones that are affected, or the range of the graph is one that is affected. Okay, let's use our calculator to just show that. Right, let's say we have our calculator. You can go to mod and then you say table. In some calculators, table will be at number 3, and then you say table, and then you can put your function. Let's say 2 cos, and then alpha. Press alpha to put your variable there, alpha x, and then close your brackets there. Okay, right. Let's draw this graph from negative 90. Let's say negative 180 to 90. Right. Just say after this, what do you do? Press equal sign, and then we don't have the second function. Let's just press equal sign again, and then start will say negative 180 because we want to start at negative 180, and then equals, and then end is what is 90 degrees. Okay, end at 90, and then step we say that the critical values are at every 90 degrees, so our step must be 90 degrees. Okay, so step is 90 degrees there, and then equals. Right, you see that at negative 180 we have negative 2. That's where the graph is. Negative 2 is here, right? And then at negative 90 the graph is at 0, is here. And then at 0 the graph is at 2, like that. And then and then what do we have here? Let's check. At 90 is 0, and then we said from negative 180 to 90, so at 90 it is a 0. And then if we sketch the graph, it's going to be just like this. Okay, you have used your calculator to just find your critical points. We have sketched the graph of g of x from x is equal to negative 180 degrees to 90 degrees. Remember, always indicate the endpoints. Here is negative 180 degrees, and then negative 2 there. Okay, and then here we have our endpoint there. Okay, right, that's how we sketch the graph. Right, let's look at the next one. Let's say we have h of x. Let's say h of x is equal to negative cos x. You see that? Right, the a here is negative now. what will it do to the parent graph? Remember, the parent graph, you should be able to sketch your parent graph without even checking, right? Let's sketch the graph of cos x. We know that at 0 it is at 1, then at 90 0, 180 -1, 270 0, and then 361, like that. Okay, and then you have your, just remember these critical points. This will assist you a lot. Yes, you can use your calculator, but you also need to understand or to remember the critical values for your parent graph, right? This is the parent graph here. So now we're sketching the graph of h of x. Now you can even use your calculator to do that. Okay, let's say, let's sketch from -360 to 360. Okay, right, let's see what we get. You can use your calculator. Now know how to use your calculator. Just press, and then we can say negative cos, then alpha, and then where's our variable x there, then close bracket. Let's say start, ignore that, -360, and then equals, and then end 360, and then equals, and then step is every 90 degrees, so our step is 90 degrees, and then press equals, right? That you see that. And then at -360 we have -1. So let's sketch the graph now. If you check, if you plot these points, these are the points in the calculator here. Okay, if you plot these points, this one will be here, and then there, and then there, and then there, then there, like that. And then you can easily sketch your graph like that. Okay, and then we have our graph for h of x, right? H of x, which is like this. What has happened to f of x to give us h of x? What has happened? Remember, our h of x was what? Our f of x was just cos x, and then h of x is negative cos x. Do you see that our parent graph was reflected about the x-axis? See that? So when a is negative, that shows a reflection about the x-axis. Okay, right? The maximum value is still 1, the minimum value is still -1. Even the range of the graph, the range is still y greater than or equal to -1, but less than or equal to 1. So the range also is not affected. Right, now let's look at this one. Let's say we have the graph of p of x. Let's say p of x. Right, our parent graph is f of x is equal to cos x. Now let's say we have the graph of p of x, which is equal to cos x plus 2. Okay, that is the effect of q. Remember, we said we want to look at the effect of these parameters, a cos x, let's say kx. Okay, we're going to look at the effect of k, and then x plus p, and then plus q. We want to look at the effect of a q there. Okay, so we have the parent graph. We can draw very fast without even checking the calculator. You should be able to draw the parent graph so that it is easy for you to draw the other graphs. Right, and then we have that like that, and then that's the parent graph. Okay, so what should happen to the parent graph to form the graph of p of x? Okay, what's the effect of q? It means the graph must be shifted by 2 units upwards. But now the critical points are still at every 90 degrees. Every 90 degrees, that's where we have our critical values. Okay, so it means the step does not change, it's still 90 degrees. F of x cos x, and then alpha, and then x close bracket, and then plus 2, like that. Okay, outside the bracket, then equals. We don't have another function, so we press equals again. Then start. Let's say we want the domain from, let's say one from -90 to 270. Let's start from -90, and then equals, and then end, let's say 270, right, like that. And then what do we get? Step, let's say 90, is not changed. The only thing that is going to change our x will be, the only thing that is going to change our, sorry, the step will be the k, parameter k there. Otherwise, the other ones, they do not change. So at -90, we have 2. Let's sketch that. So -90, we have 2. Is -90, we have 2. And then at 0, we have 3. You see, what is happening is that every point is shifted up by 2 units. So it's like 1, 2 is now there. Then 1, 2 is now there. This one also, or the 2 should be here. This one also should be 1, 2, like that. We are moving every point upwards by 2 units. That's the effect of this Q here because it's positive 2. So we're moving every point by 2 units. So it means this point also must move up by 2 units upwards. So it's going to be there. Then this point must move up by 2 units upwards. It's going to be there. And then this point also must move by 2 units upwards. It's going to be there. But also you can read this from your calculator. We say it from negative 90 to 270, so it must end here. Okay, so we have that is the graph there. Okay, then we have sketched your graph. Okay, all right, let's say we have another graph. Let's call it what? Let's call it q of x. Let's say we have q of x, which is equal to cos x minus 1. Cos x minus 1. Okay, what will happen to the parent graph, the white graph, to give us q of x? It means every point must move downwards by 1 unit because of the negative 1 here. So it means this point should be here. Okay, let me use a different color. Let me use what? Let me use red. Right, this point should be here. Right, this point we're going to move 1 unit downwards. This one also 1 unit downwards. We say it from what? From negative 90 to 270. So let's not worry about this one. So 270 there, this one will move by 1 unit downwards. This one will move 1 unit downwards. Then this one, even 90, will move like there. It's going there. Then from 1 is to be a 0. From here is going to be like that. We said negative 90 to 270. So let's end here. And then you can sketch the graph like that. The calculator must be used with your knowledge of the parent graph, the key features of the graph. So if you just use the calculator without knowing the key features of the parent graph, it may be problematic. Right, let's move on to the next one. Now we're going to look at the effect of k. The effect of k is one which is sometimes giving us problems. Let's say we have the graph, let's call it what? Let's call it m of x. Let's say this is f of x is equal to cos x. Then let's say we have m of x, right, is equal to cos 2x. We're going to sketch this graph, let's say from negative 180 degrees and then to 90 degrees, right? Okay, so what do we do here? Again, it is very important for us to be able to know the key features of the parent graph first. So our parent graph is f of x, so which is at 190, 180, 270, and then 360. All right, and then here this goes like that. This is the parent graph. So now we want to sketch the graph of m of x, which is cos 2x. So what do you do with this k? Please be careful with k, right? Divide every x value by 2. That will give you your x-intercept. So if you say 90 divided by 2, you get 45. So it means this point is going to be here now. And then we say 180 divided by 2, you get 90. So it means 180 now, the second point critical value is going to be at 90 there. You see that? Now the critical values are at every 45 degrees if you check. Because from 0 to 45 or 45 to 90. So it means now our step must be 45 degrees. Okay? And then going also to the left, you say negative 90 divided by 2, you get your negative 45. And then negative 180 divided by 2, you get your negative 90. And then negative 270 divided by 2, you get negative 135, which is like here. And then negative 360 divided by 2, you get negative 180. So now the critical values are now at every 45 degrees. So if you go to your calculator now, you will say cos, we have cos, and then 2, the alpha x, is x, and then like that close bracket, and then equals, we don't have the second function, let's press equals again, and then let's say start, we say can say negative 180, and then equals, and then end, we'll say 90. You see that? Now this step, now you have to be very careful, is now 45 degrees, and then press equals. You see that? Now to give you at negative 180, that is 1. Negative 180, that is 1. Let's plot our 1 here. All right, and then where it is negative 135, negative 135 is 0. So it's 0 here. And then we have negative 90, which is negative 1, like this. And then we have, let's check, negative 45. Negative 45 is 0. So it's here 0 there. And then we have 0 is going to be 1, like that. And then 45, where is 45? We have 45, 0, 45, and then 90, negative 1. So 45 is 0, and then 90, negative 1. Then you can sketch your graph like this. See, it becomes very easy to do that. Please be careful with parameter k. Parameter k affects the period of the graph. So the best thing now, know the critical features or the critical values of the parent graph. Now you know your x-intercepts, isn't it? Or where your critical values are. And then you divide every x value by what? By your k here, in this case, which is 2. Then that will give you your new critical values. Now you can see that the critical values are at every 45 degrees. So that is your step now. 45 degrees is your step. Let's do another one, similar to this. Let's say this is our f of x is equal to cos x, isn't it? And then let's call this one maybe t of x. Let's say t of x is equal to cos half x, like that. Okay. And then what do we do? Let's sketch this graph from maybe negative 360 degrees to 360 degrees. Okay, these are the x values. Okay, 360 degrees to included. Just include the 360. When I'm using round bracket like this, it's like I'm not including the 360 and negative 360. Right, so square brackets meaning that included. Parent graph first. Let's say, now remember the key features of a parent graph. This is this. You see that? You should be able to do this without even the calculator. This will assist you a lot. Right, and then now our k value there is half. So we're dividing. So you're saying 90 divided by half. 90 divided by half is 180 degrees. So it means the new point now is this. Okay. And then you say 180 divided by half is now at 360 degrees. Do you see that? So now the critical values are every 180 degrees, from 0 to 180, from 180 to 360. So the critical values are every 180 degrees. Even if you come this side, you say negative 90 divided by half, you get negative 180. See that? From 0 to negative 180 degrees, that is what? 180 degrees. And then you say negative 180 degrees divided by half, you get negative 360 degrees. You see that? Okay, so it means the critical values now are every 180 degrees. Okay, so now we need to sketch this graph. We go back to our calculator. Now our step is going to be 180 degrees, but we're drawing from negative 360 degrees to 360 degrees. Okay, let me change this. Let me say, let's draw this from negative 90 degrees, okay, to 360 degrees. Okay, like that. So negative 90 degrees, where will this graph be? Where will this graph be? So you have to be careful there. Okay, right. So where do we start? Now, what we can do, we can ignore this negative 90 degrees here. You can ignore it and then start at negative 180 degrees, isn't it? Okay, and then start at negative 180 degrees. And then this will give us a nice shape of the graph. Or the other thing, okay, when you get a graph like this and then it's a bit confusing, just do every point one by one. Where is the graph starting? We want to start at negative 90. So just put negative 90 where there's x. Okay, you don't need to put the table every time. So just put negative 90 where there's x. Like you just go to your calculator the normal way. Okay, let's clear this. Let's clear this. Okay, let's clear this. Right, just say cos, and then we have our half. Okay, 1 over 2, like this. Okay, and then our x is negative 90. You put your negative 90 like that, because sometimes using a table sometimes is confusing. Close bracket, but remember you check here, we have two opening brackets, so we must have two closing brackets and then equals. So we get what? We get root 2 over 2. What is this as a decimal? It's like 0.7 something. So it means somewhere here. Okay, somewhere there. And then you go to 0. Just go back to your calculator. Where there's x, you put 0, and then put 0 here, and then put 0, and then equals. You see, we're getting 1. Okay, like that, 1 by 1. And then we don't need even the 91. Let's go to 180. So the x-intercept was 90. Now it means it's going to be at 180. And then at 180, the graph was at -1. So now it means it's going to be -1 at 360, something like that. Okay. But if you want, you can start from 0 and then end at 360 using your table, if you like the table. But now we know this point. So you can do this point independently on its own. So this is -90 and then 0.7 something. Okay, right. And then you can use your calculator from 0 to 360 with your step being 180. Let's try to do that. Right, let's say mod, we put our function. In your calculators, maybe number 3 there. Here is 7. And then we say cos, and then half 1/2, and then alpha x, and then close the bracket, and then equals, and then this is start 0, and then end 360, and then step is 180 now, 180 degrees, and then equals. You see that? So now from 0 is 1, and then at 180 it is 0, which is here, and then at 360 is -1. You see that? And then you can just plot your graph, continue plotting your graph like this. Okay, so you can use your calculator and your information about the parent graph to sketch the graphs like that. And then we've managed to sketch your graph. If we wanted to sketch from -360 to 360, then our graph was going to be like this. You see, it was going to be like this, something like that. But if you are sketching from -90 to 360, this is our graph. We have the graph of f of x is equal to cos x. That's our parent graph. Let's say now we want to sketch the graph of k. X is equal to cos x, and then plus 30 degrees. What is the effect of p if you have f of x is equal to a cos k x plus p, and then plus q? What is the effect of p? This is p, not q, right? What is the effect of p? P is for the horizontal shift. And then if it's plus, it means the graph is shifted to the left. And then if it's minus, the graph is shifted to the right. Now, again, start with the parent graph. This is the parent graph. Okay, like that. We know the parent graph is like this. Okay. And then, since our P is positive 30, it means the graph is going to be shifted by 30 degrees to the left. So every point is going to be shifted by 30 degrees to the left. Like this point is shifted by 30 degrees, so it's going to be here. This point is shifted, is now there. 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 Then this point also is shifted, is now there, like that. Okay, right? Even this one is shifted, it's now there. This one is shifted, it's now there. Okay, everything is shifted to the left by 30 degrees. So when there is a horizontal shift like this, I would advise you to do this method instead of the calculator method, because the calculator method now, it may be very difficult for you to find out where you should start. Okay, where you should start. So now let's say we want to sketch this graph from -180, from -180 degrees to 180 degrees. Okay, right. So what are we going to do? One here and then here, right? Right, every point has been shifted by 30 degrees to the left. But now, what is going to be the point at -180? Then you find this point independently. Even again here, do the same thing, find this point independently, because the points which are clear for us here are these ones that we have managed to shift by 30 degrees to the left. Now, you go to your calculator, and then let's do that. Say our function is cos, and then x, let's say x is -180, so it's going to be -180 and then plus 30. Okay, just put it as it is, and then close bracket, and then equals. See that you're getting negative root 3 over 2, which is like negative 0.86. Means this point here will be negative 180 degrees and then negative 0.86, like that. Okay, that's the point there. Please make sure you indicate the endpoint. So it means this graph must come here. Okay, and then what about at 180? So we can just, so it's negative 0.86, so 6, and then it should be negative 0.87, like that, right? And then we can come to 180. So just remove the negative there, then equals. See, we have negative same value. We have the same value, so it's going to be 180 degrees, then negative 0.87, like that. So that's what we can do when you're sketching graphs with horizontal shift. Okay, like let's say we have another one, the last one. Right, let's say we're sketching the graph of, let's say this is j of x, right, from negative 90 to 270 degrees. Again, start with the parent graph. We know the key features of the parent graph now. Right, we want to sketch from negative 90 to 270 up to here. Okay, so now what has happened? We have our p being negative 45 there. It means every critical point of the parent graph is shifted by 45 degrees to the right. Okay, when it's negative, it goes to the right. So it means this negative 90 is shifting by 45 degrees to the right, is now here. And then this one here is now at 45 degrees to the right, is now there. And then this 90 now, 45 degrees to the right, is now there. Then 180, 45 degrees is now there. So we'll need the points, like maybe so at negative 90 we'll need a point, at negative 90 we'll need a point at 270. But these ones, they're very clear. Okay, so we can just join these. And then we go to our calculator to find our endpoints. Right, let's use when x is negative 90. So our function is, right, negative 90 and then minus 45, like that. Just put in calculator, negative root 2 over 2 should be negative 0.71. So it means we have here negative 0.71, maybe somewhere here, right? So negative 0.7. So we have negative 90 degrees, then negative 0.71, like that. Okay, and then we come and calculate also this side. Where there is x, we put 270. Let's go back to our calculator. Then let's put 270 there. It's going to be 270 minus 45. Then 270. And then we get the same, almost negative 0.71. Okay, same value like that. So it means it's here. It's going to be 270 degrees and then negative 0.71. Always indicate the endpoints. That's how you can sketch the cosine graph.